Hello again. In this video, we're going to continue to look at limits that can be evaluated using L'Hopital's rule. Now, you may remember in the last video, we introduced this idea of L'Hopital's rule, and there was two cases where we could use it. L'Hopital's rule can be used in cases where the limit has an indeterminate form of either 0 divided by 0 or plus or minus infinity divided by infinity. Now, what we're going to do in this video is we're going to look at cases where we can't immediately use L'Hopital's rule because we don't have one of those two forms. But what we're going to do is we're going to manipulate the function that we're trying to find the limit of so that it does have one of those two indeterminate forms, and then we'll be able to use L'Hopital's rule. Now remember, L'Hopital's rule says that the limit of f divided by g as x approaches a is the same as the limit of f prime divided by g prime as x approaches a. Again, we only know that these are equal if you have this first limit having one of the two indeterminate forms of either 0 over 0 or plus or minus infinity over infinity. Okay, so let's look at an example of what I'm talking about. So notice in this particular example, x is approaching infinity, right? So x is just getting larger. As that happens, though, x squared, of course, is just going to get larger and larger as well. So it's going to head towards infinity. The second function is actually going to head towards 0. And that's because as x gets larger, 1 over 4x squared is just going to get closer to 0. And of course, sine of 0 is actually 0. Now, keep in mind that this actually never reaches 0. It just gets closer to 0 as x gets larger. So this is a really small number close to 0 being multiplied by a really large number. And unfortunately, we don't know what that's going to be equal to. That's why this is an indeterminate form. We call it infinity times 0. Okay, so it's still an indeterminate form. Unfortunately, though, we can't use L'Hopital's rule because L'Hopital's rule requires us to have one of these two forms in order for us to use it. That's not going to stop us because we can actually create an indeterminate form that looks like this or this. Because the only reason we don't have this is because we have multiplication and this has division. So what we're going to do is we're going to create division from this multiplication. And that's really easy to do, actually. If you take this sine function and you divide it by 1 over x squared, that's the same thing as x squared times this sine function. And that's because you remember, when you divide by a fraction, you would flip it and then multiply by it. So when you flip this, you get x squared times the sine of x, or sine of 1 over 4x squared. Okay, so these two limits are the same. But the good news is, if you look at this, this is heading towards 0 as x goes to infinity, and so is this, because it's 1 over a really large number. And so we do have this form here, 0 over 0. We can use L'Hopital's rule now. Okay, so let's apply L'Hopital's rule to this, which basically says that this limit is the same as the limit of the derivative of this function divided by the derivative of this function. Okay, so let's find the derivative of this top function. Now to do that, we're going to have to use the chain rule, because this is a composition of two functions. Okay, sine of x is the outer function, and then the inner function is this 1 over 4x squared. Okay, so let's call this y. And we're going to find dy dx using the chain rule, which says that's the same as dy du times du dx. Okay, and here we're going to let u be this inner function. And then that would mean our outer function, which is y, is going to be sine of u, right? Because we're calling this u. Okay, so dy du, right, would be the derivative of this with respect to u. Well, the derivative of sine of u with respect to u is just cosine of u. Okay, and if you replace it with the u, this is just cosine of 1 over 4x squared. Okay, now we need the derivative of this with respect to x. What you want to do before you actually find this is go ahead and rewrite this as 1/4 times 1 over x squared. And then this is x to the negative 2. And that way you can use the power rule to find this derivative. So this is because here you're just going to get negative 2x to the negative 3 times the 1/4. Okay, using the power rule. Okay, so the derivative of this top function using the chain rule is going to be this outer derivative times this inner derivative. Okay, and I'm going to go ahead and reduce this. This is the same as minus 1/2 times x to the negative 3. And of course, x to the negative 3 can be written as x cubed in the denominator. So it's the same as that. I'm going to go ahead and put that in front of the cosine function. Okay, now that needs to be divided by the derivative of this function, which we already found. Go ahead and rewrite that as x to the negative 2 and use the power rule, so you get negative 2x to the negative 3. Okay, and it may be useful to actually keep this written like this. So I'm just going to write that top one like this. So minus 1/2 times x to the negative 3. And that's because then these two will cancel out. It makes it very clear that those cancel. Then let's go ahead and flip this and multiply by it. Okay, and so we're going to get negative 1/2 times negative 1/2 times this cosine. And then we have to find the limit of that as x goes to infinity. Okay, and of course that's going to give you positive 1/4. Okay, but look, now as x goes to infinity, this piece in here is going to go to 0. And that means this cosine of 0 is going to get closer to 1. So ultimately, this is going to be 1/4 times 1. And so the limit is 1/4. Okay, so you can see how powerful L'Hopital's rule is. It's so powerful that even in cases where we don't have one of these two forms, we can manipulate it so that it has division, right? That's the issue here. This does not have division, this has multiplication. But we created division from multiplication by rewriting it like this. Now that we have it in one of these two forms, we can actually apply L'Hopital's rule, and then it becomes determinable, and it actually equals this number 1/4. Okay, it's no longer in an indeterminate form right here. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.